So this unit, we're going to talk about a specific type of function called a radical function. You guys have dealt with radicals before, and a radical is simply like a square root is an example of a radical, a cube root, a fourth root, etc. We're going to focus on radicals that are square roots, and we're going to look at how to graph them, how to analyze them, how we can solve problems with them. And a lot of what we do, especially in this first lesson, is related to what we did in the first unit, where we can use our understanding of transformations to be able to graph radical functions, as long as we know what the basic one looks like. So a radical function with a variable in the radicand. And remember, the radicand is just whatever's on the radical side. So like here, the radicand is just x, because that's all that's under the radical sign. And like I just said, we can transform radical functions if we know the basic one using the formula, and it's very similar, except we don't use f for function, because f just sort of refers to any function. Well, we have a, which represents stretch and reflection, vertical. Then we have the radical sign instead of f. And then inside we have b, which represents horizontal stretch and reflection. Horizontal shift, represented by h. And vertical shift at the end. And all the same rules apply. So as long as you know what the basic one looks like, you can graph the rest of these using your understanding of transformations. So here's what the basic one looks like. What we want to do to start with is we'll use a table of values just to set up some points. And we're going to use 0 for x. So if I plug 0 in here, what's the value of y? 0. Okay. Then I'm going to plug in numbers that I can easily find the square root of. First of all, I can't put in any negative numbers because you can't take the square root of a negative number. What might you choose for x next? Is there a smaller one? 1. Because the square root of 1 is 1. And then you're correct. The next one would be 4. And the square root of 4 is 2. So it gives us nice, clean points. And that's enough to see what the shape's going to look like. I know there's an additional space there, but we don't need it. So 0, 0, 1, 1, 4, 2, and you see it takes a curved shape. Specifically, it's half of a sideways parabola. And this is the function y equals root x. So that's the basic function, or the mother function, we call it. All other ones come from this. What's the domain of this function? X is greater than 0 or 0 to infinity, if you're using the interval notation. Which makes sense because we can't plug in a negative number for x. And the range? Sorry? 0 to infinity again, or y is greater than or equal to 0. Let's look at these next two. So I put a table, but we actually don't have to use it. Because if you think about it, just by looking at this, how would you graph it? Yeah, take this one and shift it 1 down. Okay, so it's y equals root x, moved 1 down. So we don't have to worry about doing a table of values. So I should use a different color. That's pairing. So take this point, move it one down. Take this point, move it one down. This point, move it one down. And we have that. And that's y equals root x minus 1. The domain of that one, zero to infinity. That didn't change. Or x greater than or equal to 0. The range, however, did change. Negative 1 to infinity. Or y greater than or equal to negative 1. Okay. This next one. What do you think you would do with this one? Take the original one, y equals root x, and move it 2 to the left every point. So it's y equals root x moved to left. So knowing or understanding our knowledge of transformations, we don't have to worry about doing the table. So remember, we're taking the original one and moving every point 2 to the left. And we're going to get this. And that's y equals root x plus 2. The domain of that one would be negative 2 to infinity, or x greater than or equal to negative 2. The range would be 0 to infinity, or y greater than or equal to 0. Okay. Okay. Those were pretty basic transformations. Let's get a little bit more complicated. And remember, you can do this one of two ways. You can think of 0,01142. So you can think of y equals root x and then shift that according to the equation. Or we can do mapping notation. So for all of these, for y equals root x, I'll put it here. So I don't have to keep writing this over and over. For the coordinates, we will have 0, 0, 1, 1, 4, 2. What would the mapping notation formula for this one be? X plus 3, y minus 2, correct. So we take all the points from root x and apply the formula to the x and y coordinates. So we're going to get 3, negative 2. And we're going to get 4, negative 1. And we're going to get 7, 0. And that should form a sideways parabola, provided that I did all the points correct. 3, negative 2, 4, oh, sorry, even go on the side. Sorry about that. 3, negative 2, 4, negative 1, 7, 0. There's our first one. For our second one, y equals 4 root x plus 2. What would the mapping notation formula be? X minus 2, 4y. So again, we go back to these three, and we're going to get negative 2, 0. And we're going to get negative 1, 4. And we're going to get 2, 8. So negative 2, 0, negative 1, 4, and 2, 8. And you can see that does make sense because it did shift to the left and we stretched it vertically. So we took this one and pulled it up. This last one, this is you got to think about this one first. See anything wrong with this to begin with? Yeah, there's minus 3 here, and anything in here? That's not the way it normally looks, is it? It's reversed. So what we need to do is manipulate the equation. First of all, we'll move the minus 3 over to the other side. And you see it becomes a vertical shift. Now we've got to put the x first. So we've got to change the order inside the radical sign to negative x plus 2. And then we have a plus 3 after the radical. That's it. Whenever we have a horizontal shift, and if there's something in front of the x, don't we need parentheses? Doesn't that mean we have to factor? I have to factor out a negative 1 to be left with x minus 2. Now, it's correct. So watch out for that. If there's a value of h and something in front of the x, there has to be parentheses between that something and the x, which means it has to be in factor. Now we can finally get the transformation equation. What would it be? Negative x plus 2 y plus 3. So we take our 4 points from the original. Negative 0 plus 2 is 2. 0 plus 3 is 3. Negative 1 plus 2 is 1. 1 plus 3 is 4. Negative 4 plus 2 is negative 2. And 2 plus 3 is 5. So what it should look like is it's shifted away from the origin and it's stretched horizontally. Or sorry, it's flipped horizontally because of that negative. So it flips this, so it should be going that way. So 2, 3, 1, 4, and negative 2, 5. And we see, in fact, it does go the other way, which makes sense. See if you can do the last one. Colors. Try that one. What's the mapping notation formula? Half x, because when we pull it out of the equation, we take the reciprocal, negative y. So for the first coordinate 0, 0 in the original, half of 0 is 0, negative 0, still 0. For 1, half of 1 is a half, and negative 1, well, becomes negative. And then for 2, half of 4 is 2, and then we should get negative 2. So we should have something flipped like this and stretched this way. 0, 0, 1 half negative 1, 2 negative 2, and it's actually stretched, compressed a little bit. Looks very similar to the original, or without the horizontal stretch, but there is a stretch there. Okay. So that's graphing radical functions using transformations. If you're given the equation, how to graph it. And remember, in the last unit, we also talked about how to work the other way. What happens if you're given the graph and asked to write its equation? And notice in the black there, that's the original one. That's y equals root x. So again, and actually this is a little bit easier than the ones we did in the last one, because we don't have to worry about doing the flips and stretchings first and then take a point and see where it goes to see if there's a shift or shifts that take place. We can actually do it all in one shot. So for A, and I guess B, did it flip? Neither way. So A and B are going to be positive if they exist. Now this is where you got to be careful looking for the stretch, because you should see that there is a stretch. The question is, what kind of stretch? Well, if you look at the original, to get from the first point to the second point, we go across 1, up 1. But from this one to get to the first to the second point, we go across 1, up 2. That means it was stretched vertically. So instead of going 1 in the original, it went 2, which means A must be 2, and there's no horizontal stretch. Or sorry, yeah, no horizontal stretch. And now, did it shift? Did it shift? Down 1, didn't it? Here's the original starting point. Here's where the new one starts. No horizontal shift, but a vertical shift down 1, which means negative 1. And then we simply write the equation. Remember, if there's nothing for one of the letters, don't write the letter in the equation. Just leave it completely out. So A is 2. Radical sign. Nothing for B. And nothing for H. So really just the X goes there. A little bit extra on that. H. And then at the end, we have a minus 1. See if you can figure out the second one. Anybody want to take a shot? No? Yum?
Okay, I know that there's like a horizontal stretch, but not part yet, but I did like
Is there a horizontal stretch though?
this.
like if you look at the original, remember, to get from the first point to the second, we go 1. Same thing happened here. Okay, so square root x plus 2 minus 3 plus 3. Good. Yeah. No stretching or flipping took place. It just moved 2 to the left, which means h is -2. So when we plug it into x minus h, it's x minus -2, which is x plus 2. And then this is 3. Something that you might see as an example like the last one. Asked to find the equation of a radical function, but you're only given the domain and range. And you're given it in set notation. Remember, this is everything greater than or equal to -3. So if you want to convert this to interval, it's going to look like that. This is everything greater than or equal to 4. So we start at 4 and we go up to infinity. Okay? Well, one way you could do this is do a quick sketch of it. And then get the domain and range drawn. I didn't do that. No. I just keep putting those things in. Okay, good. Just gonna keep it like that. So it starts at -3, like the furthest x value is -3, and then it goes to the right forever. So if we go here, it starts somewhere here, and then it goes this way. Okay? The range tells us that the lowest value is 4, and it goes up forever. So the lowest value is 4, so it's a point on this line, and it goes up forever. What am I doing wrong? -3. Thank you. I feel you guys getting uncomfortable. Sorry. So it's got to be here and here, which means the point must be there. And it has to go in this section, so it has to look something like that. So now we should be able to translate that to an equation. Because we moved to the left 3 and we moved up 4. No stretching or flipping going on. So we move to the left 3, which means inside the radical it is x plus 3. And then it also moved up 4, which means at the end we need plus 4. So if you see a question like that, some of you may be able to do it without a sketch to say, oh, okay, well, I know that it moves 3 left and then 4 up, so it must start at -3, 4, and then go from there. But I always find if it's a little unclear, a sketch helps.
I don't think